this slide, then everything went down. And what I was talking about is, you see the Spark architecture. So if you want to program in Spark, like I said, there are two ways to program in Spark. One way is that you can write all your code using a programming language like, let's say, Python or Scala or Java or R. That is one way. The other way is I can use SQL. So, and SQL is more popular when it comes to the Spark world. Most of the code actually is written using SQL. And we saw this slide. Now, Hadoop versus Spark, right? So like I said, if you ask me like what will get replaced, let's say you are working for a company and you have a Hadoop installation, and now I'm planning to migrate to Spark, what changes will happen? First of all, Spark can be installed on top of your existing Hadoop cluster. So there is no need to delete anything. You can, on your existing Hadoop cluster itself, you can install Spark by Spark. That is for sure. So if there is something which gets replaced as an execution engine, that will be Mapreduce. Mapreduce will be replaced by your Spark execution engine. Now, for cluster manager, like I told you, there is something called Yarn on top of Hadoop. So Spark can use Yarn. Spark can also use another cluster manager called Mesos. So Mesos is another cluster manager, which is not on Hadoop, but the slide is just telling you that Spark can either use Yarn or Mesos as the cluster manager. And when it comes to the storage, if you're running on top of Hadoop, it will be HDFS. And the other engines, for example, like Hive. So on top of Hadoop, we already have a SQL engine called Hive. So this can be replaced by Spark SQL. And for machine learning, there is an engine called Mahout on top of Hadoop. This can be replaced by Spark MLlib. And there is something called Storm, Apache Storm, right? That is for real-time data processing. This can be replaced by Spark streaming. So what we see here is that in the Hadoop world, you are having three engines for three separate tasks. Like for SQL, you have Hadoop, machine learning, you have Mahout, real-time analytics, you have Storm. All three can be replaced by the single Spark engine. The only thing, you need to use the corresponding libraries within Spark. For example, for replacing Hive, I will be using Spark SQL. For replacing Mahout, I will be using MLlib, and Spark streaming for replacing Storm. Okay, so we also know, so why Spark is replacing Mapreduce, or what are some of the drawbacks of Mapreduce? Probably people are interested to know. See, there are a couple of drawbacks related to our Mapreduce. The first drawback is that Mapreduce cannot be used for iterative processing. So there is something called iterative processing or iterative processing, you call it. See, Mapreduce cannot be used for that. What do you really mean by iterative processing? See, iterative processing means in case of machine learning and all, you will be taking one data set and then over and over you will be going through that. Called iterative processing. So Mapreduce is not good for iterative processing. Point number one, right? It is a back of read and write from the hard disk. So what is going to happen is when you are running a Mapreduce program, there is something called mapper which runs first, and the output of mapper is stored in hard disk. Then again, what is going to happen? The reducer is going to read this from the hard disk and then run it again. So Mapreduce actually is very slow because the intermediate results are actually returned to the hard disk and then again read from there. In case of Spark, what we do, there is something called in-memory processing, meaning Spark is going to read your data into the memory, that is RAM, and then do all the analysis, and only the final output is going to get stored. So since Spark does in-memory processing, it is considerably faster than MapReduce. So in lot of the benchmarking test and all, it was found that Spark programs run at least 10 times faster than MapReduce, and in many cases up to 100 times bigger than MapReduce. So that is the speciality of let's say MapReduce and Spark comparison. And this one we will come in a moment, this slide. And now let's talk about something called RDD, right? So the basic abstraction that you use in Spark is called RDD. And probably I will, rather than talking about it like this, I will draw it so that people can understand what it is. By the way, are you able to hear me well and then see my screen? I mean, why am I asking this? Because I'm using a separate internet connection. Is this voice and video, everything fine with you? Are you able to see the things I'm showing you? Tushar says, my voice is cracking. Okay, so let me just see if I can switch. Give me a moment. Give me one moment, okay? Can you tell me how the voice is now? Can you tell me how the voice is now? Now better? It's better, right? Okay, thank you. Clear, right? Thank you. Yeah, so yeah, I'll just resume the share. Thank you. So what we are talking about is that whenever you want to process the data in Spark, what we do is very simple. You will have, let us assume that you are processing a single file. So this is my file which I want to process. Okay, and let us assume that this is a CSV file. It can be any file. Okay, I'm just giving an example of CSV. Let us assume this is a CSV file. Now this file, let's say, is 10 GB in size. So this file is actually in 10 GB in size. And let us assume you want to read this file and process it inside Spark. So I have a Spark cluster. Let's say I have 2 machines here. And when I want to process this file, what I will be doing is that I will be splitting this file into 2 in this example. So one part here I will be loading. So this will be like 5 GB. And one part here I will be loading. That will be again like 5 GB, right? And then I will be processing them parallelly. So any file that you want to process, ideally we partition the data. This concept is called partitioning or partition, right? Now in this simple example, I'm dividing a 10 GB file into 5 GB, 5 GB. But in the real world, probably if you have a 100 GB file, you may divide it into 100 partitions, like 1 GB, 1 GB each. That way you might have to partition the data. So partitioning purely depends on the size of data that you have. And the second thing that you need to understand is that you will be splitting them into 5 GB files each. But when you want to process this file, you will be launching something called executor. So this is called an executor. Executor. What is an executor? Executor is nothing but a JVM in simple terms. It is an environment where you can load the data and process your data. So each executor will be coming with certain RAM and let's say processing power. So let's say this executor has 8 GB RAM and 4 processors. So what you will be doing when you're running a Spark program, you will be asking the cluster manager to allocate resources to you in the form of executor. And then within the executor, you will be loading partitions of your data and then processing them. So to give you a high level overview, what we do is that you have a single file. You will say that I want to split this file maybe into 10, maybe into 100, depending on the file. Then those splits or partitions you will be loading into JVMs called executors, and your code will be running inside this JVM parallelly. So as you can understand, I can probably ask for 10 executors or 100 executors with certain RAM and load each partition of the data, and then I will be able to do parallel processing. And when you're running a Spark program, you can decide how many executors you need and how do you want to partition the data and load it into the executor and run them. So these executors are allocated by yarn in our example because we are running Spark on top of Hadoop. So the cluster manager is actually yarn. So we can safely say that these executors are allocated by our cluster manager, which is nothing but yarn. So yarn is going to give you resources to run your Spark program. Any questions so far in Spark that you would like to ask? Let me know. I can pick up some questions. No questions at all. You can type in the chat window if you want. I can give you some time to do that. Okay, I'm not seeing any questions. Let me just check. No more questions. Okay, great. So now we have to talk about something called RDD. There is something called RDD. Let me write it here somewhere. Yeah. So what is an RDD? RDD stands for Realigned Distributed Data Set. RDDs are nothing but the basic data structures that we use in Spark. So inside Spark, whenever you want to process any kind of data, you read the data and represent the data as an RDD. RDDs are special data types or data structures which are created inside Spark to help you process the data. So one of the ways in which I will be able to process my data is if I'm using RDD, right? So I can say that, hey, I have some data to be processed by Spark. Let me read the data into an RDD and then start processing my data. But if you are using RDD for processing the data, then you have to use one of the programming language such as Scala or Python or Java or R. So RDDs are the lowest level of API that we have in Spark. And when you work with RDDs, you will be writing programs using one of these languages. So if you are, let's say a programmer, a hardcore developer who want to use Spark, and you want to write low-level programs, then RDD is your choice. But in our class, we will not be discussing about RDD because, I mean, I will be showing you RDDs, but not in depth. Because if you want to learn RDD, then first you have to master one of this programming language. And in our class, some of you may be comfortable with Java, some of you Scala, some of you Python. Some of you may not be comfortable with any of these programming languages. So if I introduce RDD programming, you will not be able to follow completely. But I will give you an idea about how the RDD program look like and how it runs so that you can get an overall idea. But RDDs are the basic data structures, and anything that you want to process in Spark in the lowest level of API with hardcore programming, you will be using RDDs. Now let us do one thing. Let us connect with our lab. So let me just close these windows, okay? CloudX Lab. And Spark also has many versions. We call them as versions. So Spark has three major versions. There is the version 1, version 2, version 3, right? Version 3 is actually beta. It's very new. Version 1 is actually very old. What the industry actually use is Spark version 2. So let me connect with the web console. And log on to our cluster. And there are a couple of ways to interact with Spark. And the easiest way to interact with Spark is using something called the Spark shell. There is something called Spark shell. It is an interactive shell. So you can just type Spark shell and it will open the Spark shell for you. So let's wait for a moment. Let me also do one quick thing if you don't mind. Yes. So what did I do? I just typed the command called spark-shell. So when you type this command, you will be getting an interactive shell in the Scala environment. So as you can see, it is written Scala. So ideally, I should use the programming language called Scala to write Spark programs in the shell. But you can also write SQL. Don't worry, I will be talking about SQL mostly. So this is the Spark shell. So when you start Spark using a shell, there are some of the points which you can note down. For example, there is a version and it says the Spark version is 2.1.1. So that is a pretty stable version. It is a 2. version. We can say that is a version. It also says Spark context web UI available at certain port number. It also, so here you see Spark context available as SC. So what is this Spark context? It is an object created by Spark to communicate with your cluster manager. So no matter whatever you're doing, you have to communicate with your cluster manager, right? In our example, it is going to be Yarn. So how do you communicate with your cluster manager? How do you communicate with your cluster manager? That is through this object called Spark context object. This is used to communicate with your cluster manager. And when you are using the Spark shell, you can see that it is automatically created. That is one thing. Also, you see one thing, it says master equal to local. So this is interesting, right? So what do you mean by master equal to local? Master equal to local basically means you are running Spark in something called local mode. There is something called local mode, and local mode basically means you are running on a single machine. So by default, when you start the Spark shell, you will be running the Spark shell in the local mode. So you can see these details. It also says Spark context web UI available at port number 4048. So if I open the port number 4048, as you can see, there is a UI. So Spark also comes with a UI, a user interface, which you can see here. So right now in the UI, you are not able to see anything. That is because in the UI, it will display something only when you run a program. So we have not done any analysis or any program, so you're not able to see anything in the UI. So you just see the Spark UI, that's all. You're not able to see anything else. So we will probably go for a break, but I can wait for some time if you have any questions. Any questions, let me know. We'll resume at 8:10. I will write it here. But in case if you want to ask me any questions, let me know. Or what you can do during the break time, you can just type in the question in the chat window, or you can say that, hey, I have a question and I want to ask you once you are back, and we can discuss. So let us take a break and come back and then continue with the session. Thank you. Welcome back, everyone. Welcome back. Right. So what we discussed so far is the Spark shell and how to start the Spark shell, right? Now, in order to get an idea about how do you analyze the data using RDDs, right? Let us take a very simple example so that we can understand, right? So what I want to do now is I want to run something called a word count program. So there is something called a word count program. What is a word count program? I want to count how many times a word is repeating in a file. That's called a word count program. Okay. So it can be any text file, any CSV file, anything like that. So I already have a file called book.txt. Let me show you the file which I will be using. You can go to the files menu. You can go to the data menu. So there is a file called book.txt. Let me open the file. I think it is taking a bit of time to open the file. I think I can show the file from my PC. So here is the file. So what we are planning to do now is let us assume that you want to run the word count program on this file. So this file, this is basically a book, some book, it is talking about self-development, how do you start your own business. So I'm just using some data so that we have some words, right? Now, what I want to do is I want to load this data, this file into Spark, and then I want to count how many times each word is repeating, right? So how can you do this is Spark supports something called transformations. So if you look at your Spark documentation, so if I go here, when I look at Spark documentation and look at one of the version, there is something called RDD Programming Guide you can go through. And in this, you can see there is something called transformations. So whenever you are writing a Spark program, you have to use something called transformations. Transformations are nothing but built-in functions in Spark. So, and there are a bunch of transformations. You can see there is something called map, there is a transformation, there is filter if you want to filter the data, there is flat map, so that's another transformation. There is sample in order to sample the data. Then if you scroll down, there is a join. So these are all built-in transformations which you can use in order to write your program on the RDD side. So the first thing which I'm going to do is that I am going to read the data and create an RDD. So let me first run the command, then I will explain what it is. Data slash book.txt. So this is how you read a file and create an RDD. So the command is sc.text file, and then you give the location of the file, and you read this file, and then you're creating an RDD called book. So here book is nothing but an RDD. You can consider RDD like a variable if you want, but at least in the world of Spark. So if you're talking about variables in the world of Spark, then that can be an RDD. And one thing which is interesting is that so I know that the location of the data is here. This is the actual location. Let's say I'm trying to read a file which does not exist. For example, if I go to this location, this is a folder called data, right? In here, you can see the book.txt. Let's say I am reading a file called, let us suppose, let's say sales.csv. As you can see, there is no file called sales.csv here, right? But what will happen is that if I try to say, read the file called sales.csv, Spark will not throw any error. So this is very surprising because I'm trying to read a file called sales.csv, but what happens, it is not throwing any error. Now, why Spark is not throwing an error is because by default in a Spark program, whatever you write is lazily evaluated. There is this concept of lazy evaluation. Lazy evaluation basically means when you are running the command, when you type a command, it will not immediately initialize the variable. So as of now, when you say that, hey, create an RDD called book by reading this file called sales.csv, Spark is not actually reading the file. If Spark was reading the file, you will get an error, right? Because there is no file called sales.csv. All Spark does is it is going to remember that you wrote a command like this. It's not going to run the command. So if you want Spark to run the command for you, then you need to call something called an action. So I can say book.collect. What is this book? Book is the name of the variable or the RDD, and collect is an action. So when you say collect, you're telling Spark that, hey Spark, show me what is inside this RDD called book. Now, if I run this, I will get an error because it says invalid input exception, input path does not exist. So now Spark is actually running my program. So the point that I'm trying to tell you is this RDD creation is a lazy process. Spark is not actually reading the data when you ask it to read the data and create this variable called book. It will read it. Okay, this example, sales.csv here, right? It will read the file only when you call an action like collect on the RDD. So now you can see that you get an error. But if you're reading the book file, for example, the book file, the book actually exists. Now, if I say book.collect, you can see that Spark is printing a few lines of the file. So this is what you call an RDD. Book is nothing but an RDD. An RDD is nothing but a variable which points to your actual data. So now you have read this file into Spark, into an RDD called book. Now, the first thing that you should ask when you have an RDD is that, in this RDD, how many, how the RDD is getting created. For example, in here, you can see that this book contains your entire book, but is Spark actually reading my file, say, word by word or line by line? or paragraph by paragraph, I don't know. So to get an idea, we can actually say book dot first. There is a command called, or there is an action called book dot first. So when you call this action called first, you can see that Spark is reading it line by line, because first basically will show you the first element of the RDD. And as you can see, this is the one. Now, if you want to get the word count output, right? So let us assume that you want to get the word count output, or I want to count the frequency of words that are happening inside Spark. What we can do is we can write a program like this. So let me just get the code. If you give me a moment, just go to my Google Drive, and the code is there. Somewhere the code is there. Yeah, here. Sorry. What did I do? I think let me restore it, okay? Yeah. Just open this with Notepad. Yes, so in order to run the word count program, I'm gonna type a command. And this is the command. Yes. As you can see after typing the command, as you can see, when I did this command, I got the output of word count program. So this is how the RDD based program will look like. As you can see, this is written in Scala, right? And also this is kind of like a little bit hard to understand. But if you really want to get into that, what you did, you took the original RDD, and then you said, take every line, split the line using word. So you are getting individual words. Then you said, convert the word into a key value pair format. Then you said, count all the values of every given word. So my point is, we don't have to get into deep into the RDD based code. But my point is, if you want to do some analysis using RDDs, you should be actually writing the code using Scala or Python, and you will be using all these functions. So you have to learn what is a flat map function, what is a map function, what is a reduce by key function, what it does, and how do you supply the code inside them. But I wrote them, and finally you can see the word count output is there. So you can see order is repeating 32 times, monitoring is repeating 1 time, handled is repeating 4 times. So we are actually able to get the final output. However, the code is not very straightforward. So that is where Spark SQL can help us. So in order to demonstrate Spark SQL, I will be going to, let's say, a different platform. So if you want to use Spark, one way to use Spark is that you can definitely use this CloudX Lab. So CloudX Lab is one platform where you will be able to run Spark and any other thing. But you can also do one more thing. If your intention is only to run Spark, you can just go to this Databricks, right? So Databricks, if you open this website, there is a button called Try Databricks. I can click here. And this will allow me to create an account with Databricks. So once I create an account with Databricks, Databricks allows me to use their platform absolutely free. So this company called Databricks, they have a cloud platform where Spark is already installed. So you can use it absolutely free. You will be basically getting a single node Spark machine in the cloud with 16 GB RAM. So let us try that to talk about Spark SQL. So what I can do, I can just go to the login page of Databricks. So I already have an account and I'm just going to sign in. Okay. Now in Databricks, the first thing that you need to do is you need to create a cluster. So I can go to this clusters menu. I can say create a cluster. Let's call the cluster as board infinity cluster. And let's say the runtime version is, I don't know, 245. So this is the Spark version. Say create the cluster. So it will take a minute or two for the cluster to get created. Meanwhile, let me look at the code I want to run. We can probably look at this analysis, I guess. Yes. So it is creating the cluster right now. We have to wait for a moment for the cluster to get created. And I want to take a use case to talk about this. Okay, so what we are going to demonstrate right now is Spark SQL, right? And in order to demonstrate Spark SQL, which is nothing but the SQL interpreter for Spark, I want to pick up a use case. So the use case is like this. There is a company called Yelp. Have you heard about this company called Yelp? Let me just write it here. Have you ever heard about this company called Yelp anywhere? Did anyone of you actually see this company or have you heard about this company? Can you just quickly reply in the chat window if you're there? No? I guess no, most of you. So Yelp is not an Indian company. I don't think Yelp has operations in India. Okay, so Yelp is a US company. They are not an Indian company. Okay, and what is Yelp? So we can actually see that if I go to yelp.com, we can actually see that. Let me close these. Yelp.com. So Yelp is a local business listing of restaurants. See, you might have heard about Zomato, Swiggy, and all, right? So what is Zomato doing? So if I go to Zomato, what is Zomato doing? So Zomato will help you to order food, right? It will also help you to rate restaurants, right? For example, I can search for a restaurant. Let's say something like pizza. So I can search for pizza and you can see all the restaurants which are offering pizza. So I can go to one of the restaurant. And in Zomato, you can see the name of the restaurant, its address, the pictures of pizza, you know, what they're delivering, review, the menu item, you can book a table, you can call them. So all this information about restaurants is available in Zomato. In fact, Zomato copied this from Yelp. Yelp was the original company who started this idea of local business listing of restaurants. And Yelp is a US company. So I can go to Yelp and ask for restaurants in San Francisco. So when I do that, it is going to show me all the restaurants in San Francisco. Let's see that. So there are many restaurants, see? And I can pick up one of the restaurants and see the details of the restaurant. So when I open the restaurant, I can see that there is a name of the restaurant, the food they offer, the star rating, and you know, the reviews and their popular dishes. So many information. Now, when you talk about Yelp, right? When you talk about Yelp, uh, Yelp actually started as a startup company. So Yelp started long back. I think they started in 2007 or 2008 in US. They started as a small startup company. So, and very soon they became like very popular for ordering food and reviewing restaurants and all. Uh, One of the challenge Yelp had was how do they store the data? For example, if you look at the amount of information you have on this page, uh, how do you store the data or where do you store the data? So this is a classic big data problem. This is a big data problem. But again, the problem here is that it is not only a big data problem. You really don't know where to store all this data. So you may naturally think that, hey, we can actually store this in Hadoop, right? You can actually store this in Hadoop because Hadoop is the practical choice. But unfortunately, no, because I can actually store all the data in Hadoop. But as you know, Hadoop is a batch processing system. People may be searching for restaurants, writing my reviews, everything using the website. So I cannot have Hadoop like a transactional platform. So Yelp, the solution for Yelp was a NoSQL database called MongoDB. So there is something called MongoDB. MongoDB is a NoSQL database. So Yelp is actually using MongoDB to store all the data. And MongoDB store the data as a JSON file. There is something called JSON. JSON stands for JavaScript Object Notation. So if I go to JSON, yes, json.org. So JSON is a file format. So it stands for JavaScript Object Notation. Basically, it is key value pairs. So our problem is that, you know, the data that we have is in the JSON format, and we want to analyze this data, right? Now, to make it happen, what we can do is we can use Spark. So if you look at our cluster, I think the cluster is ready now. Yes. So if I can go to this cluster in the Databricks platform and the board infinity cluster is ready, you can see, right? Now, the first thing I want to do is I want to upload the data. Let me show you the data. So this is the file which I have downloaded from Yelp. This is a JSON file, as you can see. It is not having row column format or anything. And this basically has all the restaurants. So to show you this, let me pick up a line and then talk about it, okay? I don't know where I can show this. Let's pick it up. Yeah. So for example, this is one business. Not this, I think, yeah, this one. See, this is one business I have from Yelp. So here you can see there is a business ID, then there is the full address of the business. Then you have something called hours, when they will open. So on Monday, they close at 7 o'clock, open at 9 o'clock. On Friday, they close at 7 o'clock, open at 9 o'clock. So you can see all the days. Then you can see what is the category. So Yelp also has, you know, other kind of business. But if you look at here, you can see the categories: food, coffee, tea. and you can see the review count. There are like 35 reviews for this restaurant. The name is Starbucks, so basically this is Starbucks, right? And the state of Nevada, you can see 3.5 stars, so on and so forth. So I have the data in this format. Now my challenge is I want to analyze this data. So what are the problems that we have in analyzing this data? The first problem is the data is in JSON format, key value pair. The second problem is that it is not structured. I don't have column names or etc. So how are we going to analyze this data? So the first thing I'm going to do is I'm going to upload this data on my Spark cluster. So I can just drag and drop the file here, and it will probably take a minute to upload this file. And once you upload this file, you get an option called create a table with UI. I can just click on this, and it says you need to choose a cluster. So I can just select the cluster that I'm running, and then I can say preview the table. So my Spark will automatically scan the JSON file and show me the structure of the table that it is going to create. So one of the specialities of Spark SQL is that it can create a table from any kind of file format. And we will look into some of them in the next class, like JSON, Parquet, so on and so forth. So as you can see, it has created a table, so there is hours, latitude, longitude, name, open. So all the column names it has selected, as you can see. So a lot of them are there. And I can just say infer schema. So it will automatically pick up the schema of the file. Yes, so you can see that it has this schema. And I can just give the table name as business and say create table. Yeah, so I think it has created the table, and now I can go to here. And in order to analyze the data, I can say create a blank notebook. So there is something called notebook, and let's create something called business note, something like this. I can say create. So this notebook is the environment where you will be analyzing the data. Okay, and in here I can just say select star from business. So let's say limit 10. And if I run this query, you can see that it is able to get me the table view of this, you see. So you are able to load the data, and I can also say select count star from business and run a SQL query, and this should also show me the output. So this will tell me how many rows of data that you have. So we have around 61,185 rows. Now, if you give me one quick moment, I will look into something. Just give me one moment, okay? Let me see if it works. Yeah. So now what we can do, let me just clear this. Okay. I will just delete this probably. Say clear results, confirm. So now what we can do is, since we have a table, so I have a table called, you can also say display, then you can say business. That's do this, it will show me the table that I have. It should ideally. Let me just check. I think display may not work because that command is not supported. You have to say select star from business. You have to say limit 10. This will show you the data from the table. It should. Yes, as you can see, we are able to. So since we have loaded this table, we can ask some interesting questions from the table. For example, if you look at here, I have written some SQL queries. So the first thing will be, okay, so I need to do a word wrap. Sorry, I need to replace. I need to say wherever you see biz, I have to replace it as business, replace all. So the first thing that I want to run is select count one as business. So I just want to count the number of records. So this is something which we have already run, but let's run that. So when I run this query, you can see that the total number of listing I have is 61,184. It's a simple SQL query. Now, let us say you want to get state-wise business count. I can say select state count one as business from the table group by state. So let us say state-wise you want to see how many listings are there. I can run this query. Let it run. Yes. So as you can see in the output, it says the state is Arizona. There are like these many businesses. And the beauty of Spark SQL is not only this, you can even visualize the data. So I don't think the, let me check whether the map will work. The map is not going to work, but I can definitely go for something like a pie chart. See? So you're able to create a pie chart very easily, as you can see. So I don't know whether I can zoom in. Yeah. See, you can see each state with a color. So I can see that most number of businesses coming from Arizona because it is 41%. So I can create a pie chart as a result of this query. I can go to a bar chart and you can see which state is like highest on business. So the Databricks environment not only allows you to run the SQL query, you can also visualize it as plots, bar plot, pie plot and all. Now let us say you want to run another SQL query. So let me run the query, then I will talk about it. So you're selecting state and counting the business, you're grouping by state, order by business, descending. So again, you are counting the number of business in different states, right? But now you're actually ordering them in descending order, and I can go for a bar chart. And the bar chart clearly shows this in the descending order. And you can see that, you know, so you can even increase the length and width of the bar chart like this. See, very easy. So you can see that Arizona has higher than Nevada, then the next state, etc. Okay. And what else? Let's say you want to run another query. You want to select the name of the restaurant, star rating, review count, city from the table where star is 5. So I want to see all the 5-star restaurants. So if I run this query, you can see all the restaurants which are like 5-star and how many reviews they have got. You can see it in a very nice way. Okay. And let's say you want to find out all the restaurants in the state of Nevada with 5-star. So you can run the query like this. So this query says, I want to select, let's say, name, star, review count, city, state from the table where state is Nevada and star equal to 5. So you can see that the queries are really faster. And what is this? Okay, so this is talking about something called delta. Don't worry about it. Now, after this, let's say I want to select the state. I want to do a sum of review count and group by state. So every restaurant will be getting some reviews. I want to sum their count actually. Let's see how many reviews each restaurant has got. So you can see the total number of reviews got by each restaurant in this example. And we can again go for a bar chart, something like this. And you can go to this plot option. So state and reviews we are doing. And I think you will be able to do a sort. I don't know why we are not able to sort. Okay. Sort option is not, somewhere you had the sort option. Can just make it like this, but where is the sort option? I think here. No, I used to see a sort option. I can say sum min max, that's okay. No, I'll probably look into that later. But you can see the output anyway. And let's write another query. I want to select stars from how many stars. I want to group by star actually in the state. So I can run this query. Select stars count 1 as business from the table group by star. So you can see that, 3.5 star, there are these many businesses, 4.5 this many. So you can actually get an idea as to the number of stars and business. I can go for a bar chart again. So you can see that the most number of restaurants you got 4 star, which is great, right? And oh, I think it is actually doing a sum of this one. So I should be taking the key as stars. Yes. So, and I apply. So you can see that there is 4 star and 3.5 star are more. So most restaurants are actually falling in 3.5 star and 4 star, which is great. There are very few restaurants which are like 1 star, 2 star, etc., which is actually great. Okay. Now what we can do, we can select the state average review count and group by state. I want to find out average review count. Okay. Previously we were doing a sum. Now we are doing an average. And when I do that, you can see that the average review count for each state. This is fine. And then we can also write, let's say, a little bit complex query, not that complex. I'm selecting the state and averaging the review count and grouping by state, ordering in descending, limit 5. So let's run this query. And then we can see the output. So to summarize what we did, we were using Spark SQL for doing all this analysis on this Databricks cluster. And now what I will do, I will wait for your questions if you have any. So we have 10 minutes. I will keep myself on mute and I will wait for your questions if you have any. If you don't have any more questions, you can wind up as well. Thank you. So I will just wait.